Welcome to How Ecology Works. In this podcast, we cover all topics in ecology and how you might apply them in your future career.
All right, so I'm here with Dr. Steve Brewer from the University of Mississippi and Dr. Heather Alexander from Auburn University. And they both have been working quite a bit with fire ecology in many of our eastern forest systems, and they've worked quite a bit on the mesophication hypothesis. So I was wondering if you could take a few minutes to tell us what is the mesophication hypothesis and why should we learn about that in ecology?
So the Musification hypothesis is a hypothesis that posits that intentional fire exclusion from our forest has allowed these shade-tolerant, fire-sensitive tree species to encroach into our forest, and that they have traits themselves that promote moist, cool, humid conditions that hinder fire from being a part of the ecosystem. So basically, fire exclusion let them in, and then once they're in, they themselves, through their canopy, bark, and leaf litter traits, create a forest that is no longer flammable. That's the general gist of it.
So basically, the species that are invading after this gap in fire are engineering their own ecosystem that doesn't allow fire to be a part of the system anymore.
Yeah, so it's pretty fascinating to think about it. There's a few ways that they can do this. One is that most of these species are shade-tolerant species. So you take fire out of the system, you start to get these shade-tolerant species come in, creating even shadier conditions that allow even more shade-tolerant species to come in. And so they tend to have pretty large, thin leaves, which is a trait that allows them to absorb more light in low-light environments. And those low-light conditions that are created by the canopy of these shade-tolerant species then create shady understory conditions. So it's cooler, it's moister, it's more humid beneath them. And what that does is it creates a fuel bed. So anything that would burn in the understory is hardly any herbaceous species hanging out there because there's just not enough light, and those are often pretty flammable fuels. But then it creates a leaf litter fuel bed that tends to be pretty moist and not flammable.
Steve, I was wondering if you could add to that what Heather was just saying about the loss of the herbaceous species in the understory. And you have this process playing out. How is that affecting the community and a lot of the wildlife species that we would normally see in that community once this mesophication process starts playing out?
Yeah, sure. So you've got, with the mesophytes coming into these upland forests and creating shade, as Heather was saying, that basically has created an environment that's not favorable for a lot of herbaceous species. Some of these herbaceous species, like some of the blue stem, broom sedge, warm season grasses, are very important fuel species. They are highly flammable. They're even more flammable than oak leaf litter. And so with the loss of those species, you're going to be losing a lot of flammability. Another thing that happens with mesophication and increased shade, reduced fire, is that this has a very strong negative effect on legume species, the herbaceous pea or bean family species. These are really important wildlife species. Northern bobwhite quail, a good bit of its diet, includes a lot of these legume species like partridge pea and tick trefoil and things like that. And so there's been a loss of these very important wildlife food species. And also, I'll just point out that those legumes also have an important ecosystem function too, in that they help to retain nitrogen in the system by being nitrogen fixing species. And so even though fire itself may actually cause some loss of nitrogen, that may be compensated by legumes being favored by fires in these systems. So you really lose a lot of wildlife value from not just from losing the regeneration of oaks, but also from losing a lot of these herbaceous species. And it's hard to get those back. You have to get fire in the system, but you also have to have increased light. You have to have both of those. And since a lot of the mesophytes that have come in and have not been burned in a long time are now large enough to survive a lot of fires, reintroducing a fire, which may be a very low intensity because of the low flammability of fuels, and combined with the large size of these mesophytes, is just not going to do much, I think, to restore that system. What mesophication is doing is creating a new kind of quasi-stable state. In order to get out of that, it's going to take effort. It's going to take going in more than just putting back in fire. It's going to require going in, opening the canopy, maybe through mechanical or chemical means, and then reintroducing fire. And even then, it's somewhat difficult because you kind of have to wait for the herbaceous community to come back. And so it's challenging. It's challenging to do it, but it can be done.
Very interesting. So you named some of the species that were important in the community to carry fire and as part of that herbaceous layer. What are some of the most important mesophyte species that are facilitating this transition in the eastern U.S.? Probably
the number one species that's mentioned is Acer rubrum or red maple. Has such a widespread distribution, so it's well known throughout the central hardwoods region, southern Appalachians. It's also common in the coastal plain as well. Here in the southern United States, in the coastal plain, I would argue that sweet gum, liquid ambar steraciflua, is another mesophyte that has benefited greatly from fire suppression, fire exclusion. And what's interesting about the mesophytes, I think the key should be focused on kind of their fire sensitivity and their kind of, their affinity for more moist environments, okay? Because when you talk about, some people will say, oh, they're late successional species. Well, that's not entirely true. Sweet gum is not considered a late successional species. Red maple is kind of not really a late successional species like sugar maple is. It's kind of all over the place in terms of, its successional status. So but you will also get some species like American beech that will also benefit from mesophication and fire suppression. So it's not just succession, I would argue. It's really about the suppression of fire and favoring species that historically lived in habitats that did not experience fire. And if we want to take it one step further, kind of to support that hypothesis, there's also been in some places xerification as a result of fire suppression. That is, you get these species like eastern red cedar that were either in mesic areas or in some cases very dry, bald areas at high elevations in the mountains or whatever, and they have come down into areas that historically were not as dry, but they were maintained by fire and not by just simply having dry, poor soils. So this is a pattern that we see throughout the southern United States, and the common denominator seems to be this loss of fire from the system.
So, Heather, I was curious if you could or if there are any other species that you think of, but also I know you've worked in several different contexts within different forest ecosystems. Does this process and are the same species driving the process in these different ecosystems?
It's quite interesting because I worked a lot in upland oak forest in the Appalachian Central Hardwood region, and I'm recently starting to work in more pine systems in the Southeast. And mesophication seems to be a trend across those systems if you remove fire from the system. So in a lot of pines, Steve mentioned sweet gum, which is a really problematic mesophyte, but you also have species like water oak that tend to encroach into pine systems, and they have mesophytic properties. And so they have, create shady conditions in the understory. They have leaf litter that holds a lot of moisture. Another cool thing that mesophytes can do, and you often see this that I wanted to point out because we think a lot about how they change, habitat for wildlife, but they also change the way that water enters a forest, the way that precipitation moves through a forest, which is super important, right? Because that precipitation delivers nutrients, and of course it's water for the ground beneath the forest. But a lot of mesophytes have really thin bark and a super wide canopy because they are shade-loving trees, and they're not used to growing in fire-prone environments. You don't need a thick, rough bark to protect you from fire. So a lot of them have this thin bark, dense canopy, and they funnel a lot of rainwater as what's called stem flow. So it's basically rainwater that moves along the branches and the trunk of the tree and is deposited in a pretty narrow region at the trunk of the tree. They funnel a ton of it. We did a study in Kentucky where red maple funneled a single rainfall event of about an inch, about 40 gallons of water that got dumped within about half a meter from the bole of the tree. While a chestnut oak, which has pretty rough bark with pretty deep fissures, it was like 10 gallons. So just the magnitude of water that these trees are able to capture out of the sky and then basically feed to themselves at the trunk is just fascinating. And so that's a way that they create a moist environment. And so they're basically fertilizing, watering themselves, but they're also potentially creating a zone of high fuel moisture near the trunk of that tree and probably increasing the moisture content of their bark so that if a fire does come along, they're more protected.
Yeah, I think both of you have touched on this point, and I just want to reiterate it before we close out this session. We aren't necessarily talking about fire being removed and we just move later into succession. In fact, a lot of these species that we're talking about aren't classified as being later in succession necessarily. The real key characteristic that I'm hearing from you is that these species have characteristics that they engineer their own ecosystem to make it less flammable, as we talked about up front. That's the real key thing. It's not that we're just moving later into succession. These species are invading and actually shifting the system to be less flammable.
That's right. And some people would call that a positive feedback loop, and where they create more moist conditions. Those moist conditions suppress fire, which creates an environment that's more conducive for them, which allows them to create more shady conditions that are less flammable. So it's like a vicious cycle, right? Or a positive feedback loop.
We would call Musification.
Yes.
All right. Well, I really appreciate you taking a few minutes to tell us about this. A really interesting process, and we can certainly see it playing out in our forest across the eastern United States. And I wanted to come to the experts to tell us about this process. So I really appreciate you taking time to do that.
Thanks for having us.
Welcome. Thanks.